Hello guys, welcome to the channel. In this particular video, I will explain you the problem least prime factor. So the problem is pretty much easy and based on the Sieve algorithm. So let's start with the problem statement first. Here is the problem statement. It says that you are given a number n and you have to find the least prime factor for all numbers from 1 to n. And the least prime factor of an integer x is the smallest prime number that divides it. So this is the definition for least prime factor. And one note is given here. It says that for 1 the output should be 1 and our task is to return an array vector or list of size n plus 1 and need to use one based indexing, right? So to store the answer for each number. Let me explain. So one example is given here and the value of n is 6. So for 6 we have to first step is to make an array of size 7. So let me make it. This is an array and we have numbers from 0, 1, 2, 3, 4, 5, 6, right? These are the numbers and let me make the places for the answer. For 0, the least prime factor is going to be 0. For 1, the least prime factor is going to be 1 because it says that for 1 the number should be 1, right? For 2, for 2, the least prime factor is 2, right? 2 is a prime number and 2 divides 2, so that's why 2 is the least prime factor. For 3, again the least prime factor is 3 itself because 3 divides 3, right? And for 4, what are the prime factors of 4? The prime factor of 4 is only 2, right? So this is going to be the least prime factor, so 2 is the least prime factor. And for 5, the least prime factor is 5. And for 6, the least prime factor is 2. So the prime factor of 6 are 2 and 3, right? So what is the least prime factor? Least is going to be 2 here. So that's why I have written 2. Now the output is, from here you can see that the output is 0, 1, 2, 3, then 2, 5, 2. And you can even verify from the output, right? Now I hope you have understood the problem. Let's talk about the solution. So here I have taken 20 as the example and I have written the number from 1 to 20. And after looking at this problem, the first approach that will come to your mind is like we can iterate over all the elements, right, from 1 to n, and after this we can find the least prime factor for each number. How to do this? This is how, okay, so this is how we can do it. You can see that I have a loop here which is going to iterate from 2 to n, because for 0 I'll write answer of 0 equals to 0 and answer of 1 equals to 1, right? So I'll start from 2 and for the current number, let's say the current number is I, any number I, so I have to find the least prime factor. How to find this? I'll simply start a loop from I equals to 2, j equals to 2 again, and j is smaller than I, so I is any random number here in this loop. So after this I'll find the first number that divides 0 and that number is going to be the first prime factor. And what is the reason for this? The reason is simple, that let's say the 2 divides let's say 2 divide the any number which is 8, right? So 4 is also there which divides 8, but as we are starting from 2, so you can see that first we will visit 2. Similarly for 3 as well. So let's say I have the number 9, so 9 can be divided by 9 as well, but I will first go to 3 before 9. So that's how it is going to work. And the complexity of this approach will be O of n cross n, right? So this is the first approach that we have, and of course this is going to show you like time limit exceed error, because we can optimize this, we can optimize it. So let me explain the optimal approach. This problem can be seen as a problem based on Sieve algorithm. Sieve algorithm, and this is very important algorithm. I hope you guys are aware of the like this particular algorithm, and all we need to do is just need to do slight changes in this algorithm, and after this we will be able to solve the problem. So first of all, let me explain what exactly is Sieve algorithm. In Sieve algorithm we generally use this algorithm to find the prime numbers in a range from 1 to n, right? How we do this? We will start from 2 and then we will we will visit every multiple of 2. So the first multiple is 4, and after this we have 6, then 8, then we have 10, similarly 12, 14, 16, 18 and 20. This is how we can visit. After this we will come to 3 and then we will visit all the multiples of 3. So 6 is already visited, then we will visit 9, then I will visit, okay, 12, then 15, then 18, then like 21 is not there. So similarly I'll do 4, 4, 5, 6, all numbers, right? So let's say I'm at 5, so I'll visit, first of all I'll visit 15, already visited, 20 is already visited, 10 is already visited. Similarly, what about 7? 6, and for 6 we have 6, 12, then 18, all are visited. For 7 we have 7, then we have 14 visited, then we have like 21 which is not there. So for 9 we have 9, 18, for 8 we have 8, 16, all are visited. For 10 we have 10 and 20, right, already visited. For okay, so for 11 again you can see that we don't have any multiple. For 12 we don't have any multiple, and so on, we don't have any multiple for the rest of the numbers. Now just focus on the number which are not visited, yet. So the first number is I'm going to change the color here. So let me take green color. The first number which is not visited is 2. Then we have 3. So all these are prime numbers. 5 is a prime number, 7 is a prime number, 11 is a prime number, 13 is a prime number, 17 is a prime number, and 19 is a prime number. So this is how we can get all the prime numbers using Sieve algorithm. And how we implement this? This is really interesting. Implementation is very important and interesting. Why important? Because this is going to make the time complexity O of n log n, and this is very less when we compare with O of n square, right? So now let's talk about the code, and I'll just do a slight modification in the code along with the intuitive explanation, then you will get the clear understanding. So first of all, let me write the code. For I equals to 2 and I smaller than n and I plus plus, this is what we will do. After this, so we have let's say this is our array which is of boolean type, right? Okay, so even let's take this arrays of integer type and storing these numbers. So I'll simply now start second loop. For j equals to, how we start, if I'm at this 2, then I'll start with 2 cross 2, which is the second multiple of 2, then 4, 6, 8. This is how I will move. So I'll do I cross 2, then j is smaller than, I'll write here. Okay, so let me write j smaller than n and j plus plus, right? This is what I can do. And this way I will be able to get all the multiples. So even I have to increase with j plus equals to I, right? So it will first go to 2, then 4, then 6, then 8. This is how it will move. And I'll simply do one thing, that if this array is prime, let's say this array, the name of this array is prime. So I'll write primes of uh, I'll write primes of j equals to minus 1. So what it will do is it will make all these values minus 1, the values which are not a prime number. So all these value will now become minus 1, right? And this is how the value, at last the value which are not minus 1 will be the prime number. So you can see that these value will not be minus 1 when I cut all these values. So this is what the code looks like. You can see that the time complexity is very similar to O of n log n, right? Okay. Now let me talk about the main problem. The main problem was to find the least prime factor, right? And now I hope you have understood the Sieve algorithm. So now in the Sieve algorithm, we can do slight modification. Let me explain what are the modification. So first of all, let me remove this. These are the numbers that we have. And what I can do is I can iterate in a similar manner, but I can do a different thing. So I'll start with 2, and what I'll do is I'll make this value as 2 first of all, and after this I will go to this 4, right? This is how I'm moving. Instead of I cross 2, I have to do I, right? This is going to help us a lot. So we'll start with I and we will move in a similar manner, and this should be equals to n, because we have to include n as well, right? You can see that we are making an array of n plus 1. Now what I'll do is I'll start with this 2, then I'll go to this 4, then I'll go to this 6, then 8, right? So we are going to replace every multiple with the current number that we started from, right? So now the value at 4 will be 2, then here will be 2, then here will be 2, and this simply means that this is the first value that divides this 4, right? And after this this will become 2, this will become 2, this will become 2. This is how we are going to move, right? After this I'll come to this 3. So okay, even let me write here as well. I'll simply write one thing, that primes of j is simply equals to I, and this is going to give the least like least prime factor, right? Okay, so now I'll start with 3. So I'll make the value 3 here, and after this I'll go to this 6. So the value is already 2 here. So is there any need to make this value 3? No. Why? Because we already have the least prime factor. So once we have the least prime factor, we don't need to override the values. So this is where I need to write if my primes of j is not equal to -1. Okay, so initially I have to fill this array with -1 values so that this condition can be checked like without any mistake, right? So I'll fill this array with -1, and after this we are going to change the value. So initially this value was -1, then the value becomes 2, and then already value has value has become 2 now, so we can't override the value and make it 3. Why? Because the value is not -1 now. So this is how we can solve the problem. I hope you have got the clear idea of the solution. So let me show you the code now. So here is the code. On the left hand side I have written the Java code, and on the right hand side I have written the C++ and Python code. So you can see that the first step is very simple. We are making a primary and filling the values with -1 that I have explained you. Similarly I am doing same here, and after this I am initializing the 0th and first value because these value are not going to be a part of this loop. And after this I am doing the same thing that I have explained you. The only difference is I am using a while loop here, right? So you can see that the approach is quite similar, like j plus I, this is how I'm going to move, and I'm going to start with I, and this is the main condition that I'm checking here. You can see that the same condition I have written here, right? So this is the approach. Let me show you the Python code as well. So this is the Python code. I hope you guys have understood the problem and the solution as well. So this is all about this video. Thank you.